Welcome to this explainer. Look, if you're an IT pro or an Exchange admin, you know the absolute headache of migrating environments. Today, we're diving into some fascinating source material that lays out practical, architectural strategies to literally supercharge those email moves to the cloud. Let's jump right in.
The material hits on probably the most frustrating pain point of Exchange Online migrations right away. You do all the prep, you click Start, and then you just sit there staring at a crawling progress bar for days. How do I speed up my Office 365 migration, right? It's a question we've all asked while, let's be honest, kind of questioning our life choices. Well, let's look at exactly how the documentation says we can fix that.
Here's our roadmap for the explainer today. First, the need for speed, then Exchange hybrid fundamentals, adding multiple endpoints, external publishing options, and finally, Exchange Online configuration.
Section 1. The need for speed. Let's find that bottleneck. So, according to the architecture guides, the standard hybrid wizard usually sets you up with a single migration endpoint. And honestly, that's exactly like forcing a massive, multi-lane highway of data through a single toll booth. Everything gets squeezed through one external name fronted by a load balancer. It puts a hard limit on the amount of data you can move in a given time. Sure, it works, but man, it is a massive bottleneck when you have heavy data to move.
Section 2, Exchange Hybrid Fundamentals. Let's quickly establish our baseline.
When we look at the core components connecting your on-prem environment to Office 365, the absolute key player stands out. It's the MRS, or Mailbox Replication Service. The MRS proxy component sits right on your Exchange client access servers, and it handles all the heavy lifting, messaging, calendaring, and free busy data between environments. Now currently, that single migration endpoint points all your Office 365 traffic to one load balancer, which then blindly distributes it to your back-end servers.
And this really brilliantly illustrates why we go through all this trouble in the first place. We rely heavily on the MRS proxy and that hybrid setup, so users, like our example user Sally Coexistence, experience absolutely zero disruption while we migrate their data behind the scenes. They can still look up free/busy times, send emails seamlessly, the whole shebang. So our goal today is to dramatically speed up that data transfer without breaking this seamless experience for Sally.
All right, Section 3, adding multiple endpoints. This is the core solution.
Now, there's a really interesting contrast here that shows exactly when you outgrow that single toll booth, a single endpoint. It's perfectly fine for small organizations. But if you span multiple data centers or servers, the documentation strongly suggests you need multiple endpoints. It gives you vastly faster throughput. You just need a bit more careful DNS and SSL planning on your part to pull it off.
So what's the core concept here? Well, instead of using one single load balancer name, like mail.practical365.com, this strategy bypasses that single front door entirely. What you do is configure separate, individually named endpoints. Think MRS1, MRS2, and MRS3, and then you map them one-to-one directly with the individual Exchange servers running the MRS proxy.
Now, obviously, this means updating your certificates. Your SSL certificate is going to need subject alternative names, or SANs, for each of these new endpoints, right alongside your standard AutoDiscover and main domain names. Or, hey, a wildcard certificate works perfectly here too. But here is the really amazing detail. While your DNS and certificates get updated, your existing Exchange Web Services virtual directories remain completely untouched. You can actually transition to this high-speed approach without breaking any in-progress migrations. How cool is that?
Moving to Section 4, External Publishing Options. Time to safely expose those new lanes.
So how do we safely open these new lanes to the internet? The simplest option presented is direct firewall NAT mapping. You literally configure the firewall with a separate external IP address for each individual Exchange server. Then, you set up a NAT mapping to forward traffic received from Exchange Online directly to the internal IP of that specific server. Just make absolutely sure TCP port 443 is open exclusively to Exchange Online IP addresses.
Now, I know exactly what you're thinking. You're saying, my security team will absolutely never allow direct external publishing to an internal server. And fair enough. If that's the case, you can achieve the exact same result using your existing load balancer. You just configure separate virtual IP addresses, VIPs, for each endpoint name. Honestly, this actually gives you more flexibility anyway. You can use Layer 7 capabilities to restrict the published URL strictly to the MRS proxy path, or allow the backend to switch if a single server fails. Whichever publishing method you end up choosing, there is a massive benefit here for global organizations. If you have a multinational deployment, you can publish migration endpoints in each physical region. To put that into perspective, it means a mailbox in Mexico moving to the cloud can actually use a server in the US rather than traversing the wide area network all the way to Europe just to migrate. Regional endpoints mean regional data processing. It is just incredibly efficient.
Section 5. Exchange Online Configuration. Let's connect the pipes.
To actually execute this, the required PowerShell commandlet is surprisingly bite-sized. Once you're connected to Exchange Online, you use the new Migration Endpoint command. You just specify the unique name and the remote server FQDN, for example, mrs1.practical365.com. Run this for MRS1, then again for MRS2 and MRS3, and boom, you've registered your new direct lanes right into Exchange Online.
The final step is just turning on the engine. Instead of lazily dumping new migration batches into the default endpoint, you manually select a specific endpoint for each batch. By deliberately spreading your concurrent batches across MNS1, MNS2, and MNS3, every single lane of your new highway gets used efficiently. And like we talked about, make sure to align those regional mailboxes to the respective regional endpoints.
Which leaves us with a final challenge based on this material. Take a hard look at your current migration strategy. Are your regional mailboxes mapped to the right endpoint? Or are you still forcing all your global traffic through a single toll booth? It might just be time to open up the highway.